Hi everyone and welcome to Activity 34. Today we are going to talk about matrix basics. What is a matrix? Well, a matrix is a rectangular array of numbers, real or complex, arranged in rows and columns. We typically enclose these in brackets. So it's kind of like organizing a table of data, if you want to think of it that way, in this numerical sequence. Again, rows going across, columns going up and down. And each of these numbers represent a different entry within this. So notice we name the overall matrix with an uppercase letter. In this case, our matrix is named A, versus when we have a particular entry that's going to be a lowercase letter. Now, if I want, let's say, to talk about specifically the 2, that is in row 1, column 2, so we would say that A12 is 2. Or if I want to talk about 7, that's in row 3, column 1, that's 7. So again, you see on these, the rows dictate first, columns second. That's also going to play into the overall dimension. And again, your dimension is always going to be read as row by column. So for this particular example, this is a 3 by 3 matrix because there are 3 rows and then 3 columns as well. So that's why I would say this is a 3 by 3. So always R by C. So if we state below, we have 1, 2 rows, 1, 2, 3 columns, so this would be a 2 by 3 matrix. On the next one, we have 3 rows, and we have only 1 column, so this is a 3 by 1. In the next one, we have 1 row, but we have 3 columns, so this is a 1 by 3. And then our last one is a 2 row by a 2 column, and that's going to be, so that would be a 2 by 2. Right, try the others on your own. All right, now notice with addition and subtraction of our matrices, this can only be done if they have the exact same dimensions, right? We must have the exact same size, and then you are going to add or subtract the corresponding entries in each. So for number 9, we are good to go because these are both 2 by 2 matrices, and if we want to add them, they match, so that's going to work out for us. So in order to add, we're going to take entry 1, 1 and add that to entry 1, 1 of the second, and then row 1, column 2, those will get added. Row 2, column 1, so 3 plus negative 2, and then row 2, column 2, 4 plus 1. So kind of combine those terms, 2 plus 0 is 2, 4, 1, 5 for our addition. The next one, we are doing subtraction. So same idea, we're going to take those corresponding entries. This time we are going to subtract away, though, the elements of B from A. So 2 minus 0, negative 1 minus 5, 3 minus negative 2, and then 4 minus 1, for a total of, when we finish simplifying, 2, negative 6, 3 plus 2 is 5, 4 minus 1 is 3. All right, now order is important with subtraction because we, in number 11, we'll need to kind of go the opposite way. We're going to take matrix B first and subtract away A. So 0 minus 2, 5 minus negative 1, negative 2 minus 3, and 1 minus 4. So our final simplified matrix would be negative 2, 6, negative 5, negative 3. All right, now for our last example, B plus C, C is 2 rows by 3 columns, so a 2 by 3 matrix. If we are trying to add up matrix B plus matrix C for number 12, that's going to be not possible because we must be the same dimensions. Okay, a 2 by 2 is not going to be able to be added to a 2 by 3. So the last one, not possible. Now when it comes to scalar multiplication, this is the idea that you are essentially distributing through a scalar through your matrix. We have this matrix, we have some kind of scalar, and think about it, it almost gets like distributed through to every single element in there by whatever that scalar might be. So we see on the next page a bunch of different matrices, and we want to multiply them by a scalar and then maybe do some addition or subtraction. So for instance, B, we have a scalar of 2. So essentially we are taking 2, and you want to think about basically distributing it to all 6 of our elements inside here. So our doubled scaled piece here, 2 times matrix B would be 2, 1, negative 18, 0, negative 12, and 30, because we're just going to take each of those entries and double them. The next one, okay, I normally like to, when I start, distribute through a scalar first and then combine the new matrix with my original. But we want to be careful on this one because after we distribute this time a 2 to matrix E, the 2E matrix is going to just be all of these doubled. So 2, 4, 6, 8, 10, 12. However, when we try to add our matrix A plus our matrix 2E, these do not have the same dimensions overall. So because we have a 2 by 2 and a 2 by 3, those cannot end up being added together, and this ultimately becomes not possible. All right, our last example, we have 4 times D, which would be 0, negative 32, 20, 40. 2 times 4 is 8 divided by 3, so 8/3. And then 4 times 3 is 12, so there's 4D. And then we're going to be distributing, notice, a negative 2 to B. So if I multiply B by a negative 2, I get negative 2, negative 1. Negative 9 times negative 2 is positive 18. 0 times negative 2 is 0. And then negative 6 times negative 2 is positive 12. Negative 2 times 15 is negative 30. Okay. So now we can combine these 2 matrices then to get our final. So 0 minus 2 is 0, or plus negative 2. Negative 32 minus 1 more is negative 33. 20 plus 18 is 38. 40 plus 0 is 40. 8/3 plus 12, might want to consult the calculator on this one. 8/3 plus 12 is a fractional number that we could turn into a fraction by doing math, enter. So we get 44/3, and then 12 plus negative 30, aka 12 minus 30, is negative 18. All right, there are 2 more for you to try then on your own. Find negative 3D, and then 4A minus 7A. Sometimes we are looking to find then the values of an equation using a little addition and subtraction. So for this first one, what I'm going to do first is I'm going to distribute that scalar through. So I still have 1x, 2, and 6 for my first. But after I distribute a negative 3, I get negative 6, negative 3x, negative 3 times negative 1 is 3, and then negative 3 times negative 2 is 6. And now what's basically happening is I want to kind of set up to solve for x and y, two little equations. So here's my x, and if I add that to its corresponding entry buddy, which is also involving an x, I know that the end result ends up being 12. So x plus negative 3x, we know will ultimately end up equaling 12. So if we combine like terms, x minus 3x is negative 2x, divide by the negative 2, negative 6 becomes our answer. And then to solve for our value of y, we're going to take the corresponding entries. So in this case, 6 plus 6 equals y. 6 plus 6 is 12, so that ends up being our y value. So again, you want to start off with these by making sure you distribute that scalar for both of these this time. So we start off with 0, minus 3, minus 9, 18. Distribute the 2. We get 2, 2y, 2x, negative 12 equals, again, that unchanged right-hand side matrix. And again, you want to line these up. If I'm solving for x, I want the corresponding entries for that. And then I also want to do the same for y. So notice y is second row, or first row, second column. So you want to line up those corresponding entries to set up your equations. All right, the last part is just a little bit of vocab. We have this idea here of what we call an identity matrix. And this is going to happen in only our square matrix. And a square matrix is when our m and our n's kind of match each other, right? These are the exact same size. So 2 by 2s, 3 by 3s, 4 by 4s, 1 by 1s, you get the idea. And in particular, these identity matrix, they are going to have where we have 1s on the diagonals, zeros everywhere else. So those will be the identity matrix. There's also something known as the additive inverse matrix, and that's basically your original matrix with all of the signs flipped, so that when you get the sum of those two, a plus negative a, your overall matrix is 0, 0. So they're showing you an example of what a would look like and what matrix negative a would have to look like, so that in order to get that sum of them, you end up getting all 0. So again, that's kind of the definition of the additive inverse, is that you end up getting a resulting matrix with all zeros, depending on what they are. All right, thanks everyone for watching. We'll work more with matrices in class.